Bismillahirrahmanirrahim. Welcome back to my channel and the series of lecture on mechanical solid. We had a very long break. I think about one month or about 1.5 months we are starting again this series of lecture. So if you recall where exactly we left, the last lecture before we finished the mechanics of solid 1 course was transformation of stresses, and we developed the equation of transformation of stresses for a plane stress. And today's lecture is a continuation of that particular lecture, and we will be developing and we will be discussing and we will be inshallah discussing the methods of construction of Mohr's circle. So today's topic is all about the Mohr's circle for plane stress. We are not discussing the state of stress in 3-dimensional. We are only discussing the state of stress in 2-dimensional, and we normally call it the plane stress. The stress is on a plane, which is on plane is a 2-dimensional. This Mohr's circle has been named after this French engineer, German civil engineer, Christian Otto Mohr, and it's more popularly known as the Mohr only, because we already know this definition, the introduction of the Mohr circle. We have already been gone through in our initial courses. So what is the Mohr circle for a plane stress? So the transformation equations for plane stress can be represented in a graphical form by a plot known as Mohr circle. So whatever we have developed so far in the mathematical form, because whatever we have done for a plane transformation equation in a plane stress, those were all this equation, and those were the mathematical equation. And now we'll be representing those equations in a graphical form, and then we will be in a position to to visualize all those transformation on a plane, and particularly in a form of a circle. And that circle is in fact the Mohr circle. This graphical representation is extremely useful because it enables you to visualize the relationship between the normal and the shearing stresses acting on various inclined plane at a point in a stressed body. So this is a graphical representation, and it's a very useful and very powerful application, because most of the students find it difficult to adopt the mathematical equations, to memorize the mathematical equation. So this tool is in fact the graphical representation, and you can see through your eyes how exactly those stresses would look like, and how those stresses can be calculated. The unknown stresses on any inclined plane, whether it be the principal stresses, be maximum plane shearing stresses, or out stresses on any inclined plane. So you will be able to see all those things in a graphical form, and you will be able to locate those stresses, the unknown stresses, within a click. You can calculate all those things. It also provides a means for calculating principal stresses, maximum shearing stresses, and the stresses on an inclined plane. Furthermore, Mohr circle is valid not only for the stresses. The circle is not only valid for the stresses, but also for the other quantities of a similar mathematical nature. Other quantities, but it should be of the similar mathematical nature, like strains, moment of inertia. So we'll be deriving the procedure for the construction of a Mohr circle for a plane stress. And it would be up to you that you extend your understanding to the construction of Mohr circle for strain, and then construction of Mohr circle for moment of inertia. So inshallah we'll be discussing the Mohr circle for the construction of stresses only. So before going into the construction of the Mohr circle, I have included 2 slides that what exactly a circle is, so that we should be able to know the equation of a circle. Then we'll be in a position to compare this circle equation of Mohr and then the typical circle equation. Then we'll be able to compare both, and then we'll see what characteristic this Mohr circle has in fact. So circle is all the points are at the same distance from the center. If all the points are at the same distance from the center, then that is known as circle. As if you recall the rectangle or square, the distances from the center are different. But in the case of a circle, from the center, all the distances would be the same. Like this is animation of a circle. You can see that this dot is rotating, and it's rotating at a fixed distance from a center point. So in fact, the definition of the circle is the set of all the points on a plane that are a fixed distance from the center. So mathematically, if you want to describe that circle, so you can define circle that set of all points on a plane that are a fixed distance from a center. Okay. So normally a circle has a radius, it has twice the radius which is known as the diameter, and then it has a circumference, and we know that the circumference is pi d, or if you want to express that circumference in the form of radius, then that would be equal to 2 pi r. So circle, if we graph this, put this circle on a graph, right, and we are putting a circle of radius r, radius 5 on a graph. So if you can see this in this particular figure, so the radius is 5. So how exactly we have the x distance is here is 3 and the y distance here is 5. So according to this is the right angle triangle, and we have the knowledge of the trigonometry, we know with the help of the Pythagoras theorem that perpendicular square plus base square is equal to the hypotenuse square. So now let's work out exactly where all the points are. We make a right angle triangle and then use the Pythagoras theorem. So x square plus y square is equal to the 5 square. So if we mark different point on this circle, and then we'll see okay, what exactly we can get. So there are infinite number of those points. Currently, if you are marking those points on each and every degree, so there will be 360 points, and if you are including the minutes and second, there will be infinite number of points on this particular circle. So here are some examples. As you can see, I've taken the example 5, 0, where the value of x is 0 and the value of y is, value of x is 5 and the value of y is 0. And at this particular point, the value of x is 3 and the value of y is 5, 4. Value of x is 0, y is 5, x minus 4, y minus 3, x 0 and y minus 5. So if we put this in a tabular form, the x square plus y square, the Pythagoras theorem will apply on all these points. So you can see, you can observe that all these points have the same distance. And this is in fact the radius square, the square of the radius. If you take the under root of this 25, you will get the value 5. And you can see that all these points are at the same distance from the center. So this is what a circle on a graph is. So in all cases, a point on the circle follows the same rule that x square plus y square is equal to the radius square. So if you can see that this particular, the center of this particular circle is at the origin. So if we take a generic circle whose center is not at the origin, so what would happen? So that would give more general case. Now let us put the center at AB. The center is at point AB. A is the distance x from the origin and B is the distance y from the origin. And this is the location of the center. And we have drawn this circle right from the center. This is the radius r. And we are saying that this is x and this point is y. For a particular point has a coordinate, and this coordinate of x and y. So the circle is all the points x, y that are away, radius away from the center AB. Right? So every point on this circle will be r away, whatever point you will take. So now let's work out where the points are using the right angle triangle, and then we will be using the Pythagoras theorem. As you can see that this is x minus a, the whole distance is x, this point is x, and if you subtract a from this, you will get this base, and y minus b would be the perpendicular. So it is the same idea as before, but we need to subtract a and b, and then x minus a square plus y minus b square is equal to rc. Perpendicular, this is the base and this is the perpendicular, is equal to the hypotenuse square. Okay, so this is the more generic form of a circle, and this is the standard form for the equation of circle. So now we know what exactly the equation of the circle is, and then we'll now, in the next slide inshallah, will be transforming the non-transformation equation into a form that will look like this equation of a circle. Then we'll say yes, this is the equation of a circle of Mohr, and that Mohr circle would be only for the stresses. So equation of Mohr circle. The equation of Mohr circle can be derived from the transformation equation that we have already derived in our last lecture. You can watch those lectures on my channel. For plane stresses, the two equations are repeated here, but with a slight rearrangement of the first equation. So I've just taken from the last lecture this particular transformation equation, and what I have done is that I have taken this particular thing minus sigma x plus sigma y plus 2 on the right hand side. It was initially in the transform equation, because on the right hand side I have just transferred it to the right hand side, where the term sigma x plus sigma y divided by 2 in equation A was moved from the right to the left side of the equation. And this is the shearing stress equation, tau x dash y dash, and these dash means this is on the inclined plane. Dash means that you had a given state of the stress, and then you have transformed that particular state of the stress, and you want to find out the stresses on an inclined plane. Initially the plane was like this, and then you have transformed into like this. So these were x dash y dash, and this is the xy. Okay, so if you want to go into detail of the transformation equation of Mohr circle, then you can watch my previous lecture. So what we will do, we will eliminate 2 theta by scaling both sides of equation A and B, and then adding the equation which yield this thing. So as you know, sine square theta plus cos square theta is equal to 1. So using this particular trigonometric relationship, we have eliminated the 2 theta term, and we are left with the expression without 2 theta. So if the state of stress at a point is given with respect to xy axis, then sigma x, sigma y, and tau xy are non-constant. Because this was a given state of the stress with respect to xy axis, and this will be given to you. This is non-state of stress. So therefore, the only variable in equation C are sigma x dash and tau x dash y dash. So equation C can be written more compactly as this: sigma x dash minus sigma average. So we have collectively called this as a sigma average. So this is the same tau x y dash, and we have collectively whatever was there on the right hand side, we are saying that to be r scale. And now you can compare this equation D with the equation of a circle, where it was x minus a plus y minus b is equal to r square. So x is x, a was the center, a, b was the center point, coordinate of the center. So instead of a we have sigma average, and instead of b we have 0. Which means the center would be of a Mohr circle would be sigma average, and the radius can be found out with the help of this particular formula. So where sigma average is equal to sigma x plus sigma y divided by 2, and r is equal to under root of this. Okay, so this is an equation of a Mohr circle. So we recognize equation D as the equation of a circle in sigma x dash, tau x dash, y dash plane. The radius of the circle is r, and its center has the coordinate sigma average 0. Instead of a and b, we have the coordinate a. Instead of a, we have sigma average, and instead of b, we are getting the coordinate 0. So now we have developed the equation of a Mohr circle, and then we'll be discussing how to construct a Mohr circle. So let us assume that we know the stresses sigma x, sigma y, and tau xy acting on the xy plane of an element in plane stress. So we are assuming that all these state of stress is known to us. We know the value of sigma x, we know the value of sigma y, and we know the value of tau xy, and we know the direction as well. Okay, so right now in this particular given state of the stress, all those normal stresses, the tensile stresses and the shearing stresses on this particular x phase is the counterclockwise direction, on the y phase it is in the clockwise direction. As we will see that this information is sufficient to construct a circle. Now we'll discuss the method of construction of a Mohr circle, and we'll see that this information is sufficient enough, and we'll be able to construct the Mohr circle with the help of this particular information. And then with the circle drawn, we can determine, once you have drawn the circle, then you can determine sigma x dash, sigma y dash, tau x dash, y dash acting on any inclined plane. You can find out so many information once you have constructed the Mohr circle. We will see. So consider the state of a plane stress as given in figure, that is characterized by the stress component sigma x, sigma y, and tau xy. Mohr circle for this stress state is constructed as follows. So we want to construct a Mohr circle for this particular stress state. So first of all, the first step would be draw a set of axes. You'll have to draw the x-axis and you'll have to draw the y-axis. So with the abscissa, the x-axis representing the normal stresses. The normal stress is the tensile stress, and that would be on the positive side of the x-axis. If it is the compressive stress, that would be on the negative side of the x-axis. And the ordinate representing the shearing stresses. The y-axis would be the shearing stresses. So first thing you'll have to do. So this is the x-axis, and then we'll draw the y-axis. So this is the first step. Just draw x and y-axis and label x as sigma and y as tau. And the next thing is plot the point label x. You have to plot this point label x with the coordinate, and x would be the coordinate that the stresses on the x phase. On the x phase we have sigma x, and then we have tau xy, right? And then point the label with the coordinate sigma y and tau xy. You have to plot these 2 points from the given state of the stress. Whatever are the stresses on the x and y phases, the x phase would be the x coordinate would be the stresses on the x phase, and y coordinate would be the stresses on the y phase. The coordinate of these points are the stresses acting on the x and y phases of the element respectively. Once you have done this, just join the points x and y with a straight line, okay, and draw a circle. So this completes your Mohr circle. As you can see, okay, these are the given state of this x is the stresses on the x phase, and these y is the stress on the y phase. So we have these 2 plane, and this x is this plane, and this y is this plane. As you can see, this x and y are 90 degree apart. They are orthogonal to each other, but in this Mohr circle case, they are 180 degrees. So whatever would be the angle here in the given state of the stress on Mohr circle would be double of that. As you can recall that there were 2 theta, and we eliminated that 2 theta. So because of that 2 theta, so whatever would be the angle on the given state of the stress on Mohr circle, that would be double of that. So here you can see that it's 90 degree. On Mohr circle it would be 180. So this x phase is this x phase, and this y phase is this y phase. Okay. So these are the coordinate tau xy, and this is the tau xy. Okay, as you can observe that on the x phase we are taking the sigma x as positive because it is the tensile stresses, and we are taking this tau xy as negative. So it means on the element the shearing stresses are in the counterclockwise direction, that would be taken as the negative. And as you can see on y phase, this shearing stress is in the clockwise direction, then we take it as a positive. So this tau is in the negative direction, and this tau is in the positive direction. Okay. And then this is the sigma y, and this distance, x distance, will be the sigma x. This is sigma x, and the center would be the sigma average. Because b, there would be no b, because it is on the on the x-axis, there would be no value of b, and the center would always cross this x-axis in a case of a Mohr circle. So Mohr circle is now complete. Note that the radius of the circle is this thing. You can find out the radius of the circle from this equation, and its center is located at sigma average 0, where sigma average is equal to sigma x plus sigma y divided by 2. With the circle drawn, we can determine the stresses sigma x dash, sigma y dash, and tau x dash y dash acting on any inclined plane. Okay, with the help of that, once you have drawn the circle, you can find out the stresses on any inclined plane. For example, whatever is the inclination of this theta, the same thing you can do on the Mohr circle. जो आपको प्लेन मिलता है, उस प्लेन से आप थीटा डिग्री के ऊपर आप इसको रोटेट करते हैं. अगर ये क्लॉकवाइज घुमा हुआ है, काउंटर क्लॉकवाइज ऊपर की तरफ घुमा हुआ है, तो आपको ऊपर की तरफ घुमा देंगे. नीचे की तरफ घुमा हुआ है, तो आप इसको नीचे की तरफ. तो जो स्टेट ऑफ द स्ट्रेस you have, आपने इसको ड्रॉ की दी है, that is the given state of the stress. And now from this state of the stress, आप इसको पॉजिटिव भी जा सकते हैं, आप नेगेटिव भी जा सकते हैं. इस केस में अगर आप देखेंगे, यहाँ हमारे पास जो उसने पर्टिकुलरली दिया हुआ है, वो उसने काउंटर क्लॉकवाइज को रोटेट किया हुआ है. तो हमारा जो भी इसके अंदर यहाँ गिवन स्टेट ऑफ स्ट्रेस था, यहाँ अगर आप देखेंगे इसके अंदर, यहाँ तो यहाँ अगर आप देखेंगे तो यहाँ काउंटर क्लॉकवाइज घुमा है, तो यहाँ आपने थीटा इसको इस डायरेक्शन में घुमाना है. यहाँ थीटा आपका इस डायरेक्शन के अंदर घूम जाएगा, ये यूं, क्योंकि वहां जो आपके पास था वो काउंटर क्लॉकवाइज घुमा था. ठीक, तो So with the help of this, we can find out the stresses in any inclined plane. With the help of this Mohr circle, we can find out the principal stresses. With the help of this Mohr circle, we can find out the maximum in plane shearing stresses. We can also obtain the principal stresses, the maximum in plane shearing stresses from the circle. कैसे करेंगे वो भी हम देखते रहेंगे आगे, हम न्यूमेरिकल भी इसकी करने हैं. So properties of the Mohr circle are the coordinate of each point on the circle represent the normal and shearing stresses. जो भी पॉइंट x और y था, x में आपने देखा था कि जो पहला कोऑर्डिनेट है वो उसका नॉर्मल स्ट्रेसेस को शो कर रहा है, और जो कॉमा के बाद दूसरा कोऑर्डिनेट है वो उसके शेयरिंग स्ट्रेसेस को प्रूव कर रहा है. इसी तरीके से y जब आपने पॉइंट आपने लेवल किया तो उसके अंदर भी आपने देखा कि पहला पॉइंट था नॉर्मल स्ट्रेसेस को और दूसरा जो था वो शेयरिंग स्ट्रेसेस को कर रहा था. सो दैट एक्ट ऑन अ स्पेसिफिक प्लेन दैट पासेस थ्रू द सिलेक्टेड पॉइंट ऑफ द बॉडी. जो भी आपके पास गिवन स्टेट ऑफ स्ट्रेस से आपने किया. इस रीजन के लिए फॉर दिस रीजन ईच टाइम यू प्लॉट अ पॉइंट ऑन द सर्कल. जैसे आपने सर्कल पे पॉइंट ड्रॉ करें, यू शुड इमीडिएटली लेबल इट टू आइडेंटिफाई द प्लेन दैट. अगर वो एक्स वाले प्लेन को कर रहा है तो आप एक्स से करते हैं, अगर वो वाई वाले पेज पे कर रहा है तो आप फॉरन उसको वाई से करें, फिर जो है इंटरमिक्स नहीं हो जाएंगे. So here is a convenient method for keeping track of the sense of shearing stress. अब जो shearing stress की sense है उसको याद रखने का एक आसान तरीका यहाँ बताया जा रहा है कि shearing stress is that has a clockwise movement about the center of the element. आप जो एलिमेंट ले रहे हैं अगर उस फेस के ऊपर, अगर आप ये ऊपर वाले इसमें देखेंगे तो ये जो मोमेंट है, ये जो मोमेंट है, ये दोनों इसको क्लॉकवाइज घुमा रहे हैं. ओके, तो ये आपके पास पॉजिटिव आ जाएगी. ये जो शेयर है, ये शेयर है, ये दोनों अगर आप देखेंगे तो ये पॉजिटिव आ जाएगी क्लॉकवाइज. तो अगर एलिमेंट को शेयरिंग स्ट्रेसेस क्लॉकवाइज घुमा रहे हैं तो दैट वुड बी टेकन एज पॉजिटिव. ऑन द कॉन्ट्रेरी, अगर वो उसको काउंटर क्लॉकवाइज घुमा रहे हैं, इसमें अगर आप देखेंगे तो एलिमेंट को काउंटर क्लॉकवाइज घुमा रहा है, ये एलिमेंट को काउंटर क्लॉकवाइज घुमा रहा है, तो फिर उस शेयरिंग स्ट्रेसेस को हम नेगेटिव लेंगे और वो जो हमने एक्स एक्सिस था उससे नीचे की तरफ शेयरिंग स्ट्रेसेस को हम ड्रॉ करेंगे. The angle 2 theta between two diameter on the circle is twice the transformation angle theta. जो मैंने भी एक्सप्लेन किया था, जो ट्रांसफॉर्मेशन एंगल आपको उसमें गिवन है प्लेन में, गिवन स्टेट ऑफ स्ट्रेस में जो गिवन है मोहर सर्कल में, उसका 2 थीटा होगा विद बोथ द एंगल मेजर्ड इन द सेम डायरेक्शन, क्लॉकवाइज और काउंटर क्लॉकवाइज. अगर उसको आपने क्लॉकवाइज घुमाया है तो आप यहाँ मोहर सर्कल पे भी इसको क्लॉकवाइज घुमा देंगे. आपने सर्कल ड्रा किया, आपको डायमीटर मिला, उस डायमीटर से जो जिस ओरिएंटेशन पे आपने उसको घुमाना था, क्लॉकवाइज घुमाना था तो आप उसको क्लॉकवाइज घुमा देंगे, काउंटर क्लॉकवाइज घुमाना था तो हम उसको काउंटर क्लॉकवाइज. ये जब हम न्यूमेरिकल करेंगे तो आप देखेंगे बड़ा इजी, इसमें है कोई ऐसे मुश्किल चीज़ नहीं. ठीक है, तो दैट वाज अबाउट द मोहर सर्कल. आई होप कि कुछ ना कुछ अंडरस्टैंडिंग आपकी डेवलप हुई है. तो इसके लिए ज़रूरी ये होता है कि आप लेक्चर के बाद बाकी अपनी और बुक्स को भी कंसल्ट करें और आपके जो क्वेश्चन आते हैं वो पूछें उनसे, ताकि जो लर्निंग का सिलसिला है वो इसी से चल रहेगा. ऐसा नहीं होता कि आपने एक लेक्चर सुना और एवरीथिंग आपने उसको अंडरस्टैंड कर लिया और लर्न कर लिया एंड देन यू डोंट नीड एनीथिंग एट ऑल. तो बेहतर ये है कि आपने इस लेक्चर को देखा, उसको स्लोली देखें, जहाँ की थोड़ी सी मुश्किल लग रही है वहाँ पास कर लें, क्वेश्चन पूछ लें, क्योंकि ये फिजिकल वो नहीं है, वो आपने ऑनलाइन सोर्स के थ्रू सीख रहे हैं. तो जहाँ कहीं आपको कोई मसला नजर आया वहाँ पास करके वहीं आपने क्वेश्चन कमेंट्स में लिख दिया या वहाँ व्हाट्सएप पे पूछ दिया या ईमेल कर दिया, ताकि आपका उस जगह पर कंसेप्ट क्लियर हो और फिर आप आगे की तरफ मूव कर सकें. तो इस वीडियो को देखें इंशाल्लाह. आपको मोहर सर्कल में जो प्रॉब्लम आती है पूछें. अगर ये इंशाल्लाह अल्लाह करे कि आपको समझ में आ जाए सब कुछ, तो इंशाल्लाह नेक्स्ट लेक्चर में हम नेक्स्ट वीडियो में हम इसका एक न्यूमेरिकल भी सॉल्व करेंगे बिफोर एंड देन विल मूव ऑन टू स्टेट ऑफ स्ट्रेस इन 3D. अभी तक जो हमने ट्रांसफॉर्मेशन इक्वेशन डेवलप की है वो 2 डायमेंशनल की है, क्योंकि एक्चुअली आप देखते हैं, आप जानते हैं कि जो हमारे पास स्ट्रक्चर है वो 3 डायमेंशनल होते हैं. तो इंशाल्लाह जो नेक्स्ट लेक्चर होगा उसके अंदर हम डिस्कस करेंगे स्टेट ऑफ स्ट्रेस इन 3 डायमेंशनल. दैट वुड बिकम अ लिटिल मोर कॉम्प्लिकेटेड एंड लिटिल मोर डिफिकल्ट एज वेल. फॉर दैट यू विल हैव टू इसको अब्जॉर्ब कर लेना और इसको अपने अंदर इस नॉलेज को ले लेना काफ़ी ज़रूरी है. ये जो प्लेन स्ट्रेस का ट्रांसफॉर्मेशन इक्वेशन है, प्लेन स्ट्रेस का मोहर सर्कल है, इसका समझ में आना जाना बहुत ज़रूरी है, क्योंकि ये कंपैरेटिवली ईजी है, इसलिए हमने इसको पहले डिस्कस किया, पहले इंक्लूड किया. तो ये चीज़ समझ में आ जाएगी तो इंशाल्लाह नेक्स्ट उसमें हम फिर मोहर सर्कल इन 3D, मोहर सर्कल में हम ट्रांसफॉर्मेशन इक्वेशन डेवलप करेंगे इन 3 डायमेंशन में, स्टेट ऑफ द स्ट्रेस इन 3 डायमेंशन करेंगे. वो इंशाल्लाह काफ़ी इंटरेस्टिंग चीज़ है, क्योंकि मैंने आपको बार बार ये कहता हूँ मैकेनिकल सॉलिड बहुत इंटरेस्टिंग है. आप इस काबिल हो सकते हैं कि आप चीज़ों को इंटरनली आप विजुलाइज कर सकते हैं कि अगर एक एलिमेंट के ऊपर फोर्सेज लग रही हैं तो विद इन दैट एलिमेंट फोर्सेज किस तरीके से चल रही हैं, कौन से प्लेन के ऊपर कौन से स्ट्रेसेस आ रहे हैं. तो इंशाल्लाह काफ़ी इंटरेस्टिंग रहेगा. नेक्स्ट लेक्चर में हम 3D में इसको देखेंगे, ट्रांसफॉर्मेशन इक्वेशंस को, स्टेट ऑफ द स्ट्रेस को. थैंक यू वेरी मच. सी यू नेक्स्ट.